Hello everyone, this is the video lecture for Pre-Calculus, section 7.3, double half product sum stuff. So, trig identities, double, half, I guess this power reducing is kind of part of it, and product sum. There's even another formula that's like somewhere around here that is not on this list, but it's on like the WebAssign super awesome formulas list, whatever. So I'm going to show you that one. It's really cool and much easier than one of these formulas when it comes up. So that's a lot to cover in just one little time, a lot to see. So I'm just going to do what we can and keep going, okay? So I'm not going to write these formulas up. We're going to see them as we go. We got 73006. So they say cosecant of x is equal to 6, and tangent of x is less than 0. That makes that negative, by the way. They're saying that tangent is negative. You know what that means? My slope is negative. It's going to be one of these quadrants here, either 2 or 4. But this guy is related to sine. If you remember, this is 1 over sine x. But this is a positive right here. This is a positive sign, a positive y value, right? That's a y value. And so positive y, yet in one of these two quadrants, it's got to be here in quadrant 2. When I start setting up triangles and all that kind of stuff, that's going to be super helpful, okay? Let me take this one step further. So indeed, it is 1 over sine. Actually, I'm going to go from here. 1 over sine. If I switch things around, my sine x is equal to 1 over 6, okay? With that in mind, I should be able to construct a triangle for what's going on. I haven't even told you what the question is. But we're going to do this first because it's important. This is an angle x. That is an angle. Just keep that in mind. My opposite is a 1, and my hypotenuse is a 6. To find my adjacent, I'm going to say square root of 6 squared minus 1 squared. That would be, what, square root 35? But notice, it's not just square root 35. No, no, no. This is quadrant 2. So what is it? It's negative square root 35. Okay? Cool. We have a triangle set up. What are they asking for? So sine of 2x is equal to what? Cosine of 2x is equal to what? And tangent of 2x is equal to what? Okay, so I'm going back to these formulas. And again, I did not write them down at the very beginning, but that is okay because you can go reference them on the sheet yourself. Let me just go ahead and give you that formula for this particular one. So I've got 2 times the sine of this guy, again, is opposite over adjacent. I'm sorry, opposite over hypotenuse. Opposite over hypotenuse, sorry. And then this guy is going to be adjacent over hypotenuse. And you can keep simplifying. 2, 36, 18 is going to be, 35, and then an 18 down here? Is that right? Yeah. There we go. My cosine formula, I guess I was just kind of squishing it way over there. My cosine formula is they have a variety to choose from. I'm just going to go with the one that I always try to remember here. So cosine squared x minus sine squared x. You can choose whatever you like. So the cosine of this guy up there, we already know, is the square root 35 over 6. And squaring that guy. The sine is 1/6. Again, we're squaring that guy. And so the square and the square root cancel. 2 negatives cancel. 35 over 36. Minus sign is retained there. 1 over 36. 34 over 36, which reduces to 17 over 18. Finally, the tangent of 2x. Its formula is, do I have it there? Yeah. 2 times tangent of x all over 1 minus tangent squared x. Okay. So what is the tangent for this? Remember that we're talking about opposite over adjacent. And so then I've got negative, I got 1 over a negative square root 35. In both cases, the negative could be going to the top or bottom. It doesn't really matter. And so I have a negative 2 over the square root of 35, all divided by, and this square is going to cancel 2 negatives, but I have the 1 on the outside is going to be retained. Therefore, I've got a 1 over the 1 over 35. Again, square and square root cancel. I want a common denominator for the bottom. So then that would be 35 over 35 minus 1 is 34 over 35. And you can certainly simplify this a little bit more. There's like a lot you can do to simplify it. But I get bored. If you can't tell, sometimes I'm sighing because it's just a little boring at times. But it just kind of depends on what the problem is. This actually ends up being when you rationalize denominator and all that kind of stuff. It's this guy right here with a 17 out of all numbers. So we got a whole lot of problems that are exactly like this. Again, we're going to be doing like 3 parts to every single question. There's going to be a whole lot of steps or who knows what. I'm not going to do every single one of these homework problems because it's very copy-paste, but they're also very difficult, and I don't want to leave you stranded, of course, but I mean, at the same time, it is a lot of the same stuff, and it gets a lot, it gets boring, I guess? I don't know. I don't want to say that on recording. Math is fun. Keep going. Notice that they're saying we're in quadrant 3 here, so for sure we're going to do this guy. There's my angle x. Again, x is an angle. I got my opposite is a negative. My hypotenuse is always a positive. Notice that makes sense the way we have it there. To find this guy right here, I would say the 13 squared minus the 5 squared. Negatives cancel anyways, whatever. I think it's just going to be a 12. Yes, 12. But now, if I just put a positive 12 there, that doesn't make sense. Again, because it's quadrant 3, we're going to have a negative 12. Okay. Now that I've set up my triangle, I need to now find sine of 2x, cosine of 2x, and tangent of 2x. I'm just following the formulas. I mean, honestly, what's going on is they're taking this angle that we have right here, this angle, and they're doubling it. So if you double this angle, it'll be way up here or something, and then what do you find for your sine and cosine values right there kind of thing? What's your x and y values? What does your triangle look like? All that kind of stuff. I don't know. And the problems don't really care about all that. They're really caring just about a formula. So we just plug in the formula, and that's just simply all we do. So we got 2 sine x cosine x. Just it's a formula. So I say I got opposite. Opposite is negative 5 over hypotenuse is a 13. Here we got an adjacent over hypotenuse. You don't have to simplify. That's good. I'll go ahead and give you the answers every time, but I mean, really, that you're fine. As far as I'm remembering, I don't think you need to simplify these numerics here. Cosine squared, sine squared. We already know what cosine and we already know what the sine is from up above right there. I'm just replacing them again. It's a 13. And again, that should be good enough. Blah, blah, blah. Do some math. It's 119 over 169. Okay. Last one, tangent of 2x. So that's going to be a 2 tangent x divided by 1 minus tangent squared x. Now, tangent's a little different. Remember that it's opposite over adjacent, so 2 negatives make a positive, so I got 5 over 12. And that's what you're going to plug into both of those places. Blah, blah, blah. Lots of little math, and you get this answer in the end. Okay. Couldn't I have just taken... This is... You know what? Funny little thing. I just thought of this. Couldn't I have said that tangent is equal to sine over cosine, right? So couldn't I have just said my sine value over my cosine value, cancel those guys out, boom. Wow, that's so fast. Of course, you'd have to do the top 2 to be able to get to that, but, you know, there are tricks, and look, this is the first time I've seen that trick at all. It's on a recording after teaching for 13-something years, so it happens. It happens. We're all learning. I'm learning. You're learning. Everyone's learning. This one's going to be, I would say, more fun because it's really a lot more thinking and just one answer instead of 3. That's also helpful to me. I got cosine squared x times sine to the fourth power of x is equal to what? And we're supposed to simplify it. Now, I am confused for sure. What I'm going to do, though, is I'm going to think back to the trig identities that we have there. So we've been using these guys a lot. But notice that we got like cosine squared, sine to the fourth. There's this power reducing formulas right here. These are pretty neat. I can actually replace my cosine squared with this stuff right here, okay? And that's actually what they're going to want to do. They have words on this problem saying blah, blah, blah. Make sure that all of your trig functions are to the first power or something like that. Basically, get rid of your powers, get rid of the square and the fourth power. So you just got a lot of sines and cosines, and it should be fine. Okay. What I do first on this one is I split it up into squares, because if you go back to the formulas, everything's squared, squared, squared. And so what I'm going to do there is say this is sine squared and sine squared. Okay. So sine squared from the fourth. Well, each one of these has its own little formula. So let me write that up. I've got my notes actually kind of changed midway. I had an x here, and my answer is all thetas, so whatever. X, theta, whatever they're wanting at the time. I'm going to use x, of course, now. So I am just copying these formulas down from my little formula sheet. These are formulas I don't ever remember myself. I mean, I kind of remember a little bit, but not enough to memorize it. So I can break these squares down. Is this good enough for WebAssign? Look, they'd all have a 1 power. Maybe. I doubt it, but maybe. So I need to simplify this a lot. Notice that we have a 1/8 that I can pull out to the front. 2 times 2 times 2 is 1/8. So at least we have that. I'm going to ask you as I keep on writing this, what do you think we're going to do to simplify this next step? Come on, can't you answer through the recording? We're going to FOIL this thing out. Expand it, I guess you can say. And yeah, that's exactly what it sounds like. So 1 times 1 times this cosine, 1 cosine, cosine, cosine. Okay. So I'm going to leave this one alone for just a minute. We'll talk to him again in a minute. Got 1 times 1 is 1. I got 2 of these negative cosines. And then I've got negative times the negative to make a positive. And you're thinking, oh no, we got a cosine squared now. True. But the thing is that I'm going to reduce that guy down here in just a moment, okay? Actually, I'm going to go and reduce it right now. I know this is going to be like really crazy. My notes kind of diverge in a weird way here. Cosine squared, we already have a formula for that. It's 1 plus cosine, and I'm doubling the inside. 2 now goes to 4. Notice that originally I had a 1, goes to a 2. Now I've got a 2 in there, so now it goes to a 4. Okay. So all of this turned into all of that. Is this easy? No, not easy at all. There's a 1/2 here, actually, that you can combine with this 1 right there. Not that that's making it any easier either. At some point, I'm hoping that you're seeing that you should try to type this into WebAssign and see if you can get the answer without having to go any further. Like, something along the way might work. Yes, I'm going to keep foiling it. And so then this guy, the 1 times everything, my cosine times everything. So here we go. I'm going to do the best I can here. I mean, I have my answer here at the bottom, and it's crazy looking, but this is looking ultra crazy. So everything times 1 is just itself. There's no change there. Cosine times this. 3/2 cosine 2x. Sorry. I'm gonna run out of room here in a second. These cosines here actually are squared. So 2 and then cosine squared 2x, but we've already dealt with that guy. We know what to do with him. And then finally over here, these are actually not squared like you would have thought. Notice that we got cosine 2x times cosine with 4x. That apparently is okay. This is the only guy that we need to actually simplify down more. Wow, I can't do it. Okay, I know. I'm gonna zoom out some. Is that zooming gonna work? Scroll. Did that? No. Oh, that's zooming in. Okay, hold on. I know. Recordings and stuff. You're getting that lecture experience. That's what it is. I don't think anything else will combine, really. Actually, no, these guys combine. Combine like terms and all that kind of stuff. So here we got 1.5 minus that, so we got basically a negative half cosine of 2x, 1/2 cosine of 4x. I guess we can rewrite that guy here in a second. So we got minus 2. If you remember, this is a 1 plus. It was a plus, right? Yeah. Cosine. We're doubling the inside to that 4 now again. These 2's are going to cancel. That's nice of them. Cosine of the 2x. Cosine of the 4x. This 1, notice that minus sign is going to have to distribute. That 1 combines with this guy right here. We got a cosine of the 4x. These guys are going to combine somehow to make a negative. Surely along the way somewhere we can stop, right? The answer is yes. Just where, I don't really know. It's going to be a negative half right here. Cosine 4x. And then finally we got a positive half where they are multiplied together. I'm looking at my answer here that I'm looking at, and it's pretty close. Pretty close. Try that out. If it doesn't work, then let me know. Honestly, if it were just me, between you and me, I would have tried something like right there and see if that works, because this is wild and crazy. Try that first. Please, just try that first. You never know. You never know. It might actually work. And then you don't have to do all that craziness that we just went through. That was just so much fun. You probably want to do it all over again. I'm not going to. Tangent of 22.5 is equal to what? Well, you think immediately to pull out your calculator, and, I mean, maybe. But we need to figure out how to do this with the trig identities. And so what I see this as is 45 over 2, right? 45 over 2 makes it 22.5. And so that's what I'm actually going to find. Well, they have a formula for tangent of something over 2. It's right there. Notice that huge formula. I don't know if you're going to be able to see it with the resolution I'm going to compress this down to. But basically, it's big old square root with a 1 minus cosine of x, and then 1 plus the cosine of x, x being our 45 in this case. I'm going to tell you that I tried it this way, and I can even see the eraser marks of what I had tried. This is not good for this problem. And I mean, it works. It will work. You'll eventually get to the right thing, but there's like a way better formula than all this. Okay? So here's your new formula. I'm just gonna give it to you. Here you go. So this is a tangent of x over 2. There's a formula right here, okay? I'm going to write formula. Write this down. It's not on your formula sheet. So tangent of x over 2 is equal to 1 minus cosine x all over sine x. And it's also equal to sine x over 1 plus cosine x. Either one. I'm going to choose this guy. And so remember that it was x over 2. And I had already reconstructed it as 45 over 2, so x is simply a 45. And so my answer then is going to be 1 minus cosine 45 divided by sine 45. 45 degrees is on the unit circle, and these values are always square root 2 over 2. Well, 1 minus this is going to be a 2 over 2, so we got 2 minus square root 2 all over 2. Big division, square root 2 over 2. These 2's cancel. And so I mean, you can leave it, anything along the way should be fine. But if you really want to like rationalize denominators and all that kind of stuff, distribute whatever's blah, 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 yeah, that's what I got. So that it's square root 2 minus 1 is what they're going to get, but I think anything along the way is okay. 73027. I've got sine of the 9 pi over 8, and I need to simplify this. Now, here's the thing. I know unit circle has like 9 pi over 4s maybe. Well, something like that. So I'm wanting to get it a 4. Therefore, I'm thinking this half angle stuff. It even might say blah, 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 half angle. So then we got sine of 9 pi over 4 all over 2. I'm rewriting it so that I can get that same thing. Look, 4 into 2 canceled, or they combine to make an 8, right? But now I've got this thing right here that I can actually utilize on my unit circle, okay? Now, you're not thinking, oh, I go looking on unit circle and I don't see 9 pi over 4. Well, notice that this would be 1 pi over 4, 2, 3, 4, 5, 6, 7, 8 pi over 4, right? Well, this would be the 9th right here. Basically, I went all the way around and 1 extra. We're looking at 45 degrees. So my formula for the sine of all this stuff, by the way, is a plus and minus the square root of 1 minus cosine of that angle all over 2. Again, I get all this from this formula sheet here. I'm just looking at this guy right there. Okay. Remember that divide by 2 just goes away, and that's the point of doing this formula. Well, again, you're thinking this is 45 degrees, and so what I actually have is square root 2 over 2. Is this good enough? Well, probably, yeah. But is this going to be a positive answer or a negative answer? I think that's going to be the big question here. Notice that I'm saying sine of this 9 pi over 8, right? This is a y value. Keep that in mind. And I want to know, where is 9 pi over 8? The original. I know that this 45 degrees is what we were using in our formula and all that, and that's nifty. But I have a plus and minus in my answer. I need to know, is it plus or is it minus? Well, 9 pi over 8, this right here, again, that's 180, right? That's 8 pi over 8. Again, just pi, basically, right? They just cancel. And so 9 pi over 8 is a little bit more than that right there. We're going to be in quadrant 3. Is my y values in quadrant 3, are they positive or are they negative? They're negative. So you know that the answer for sure is going to be a negative square root of, well, all this dorkiness here. You can definitely simplify that, like, a lot. The 2 can come up, and so then I actually get, or I guess you can distribute your denominator. That's another way. And so then you got this guy over 4. I guess I could, I don't know. What did I do? Oh, I just did magic math. Oh, I think I know what I did here. Okay, yeah. Let me show you. I'll do the best I can, okay? So that could be rewritten as 2 over 4. And I said, oh, you know what's better? Is if I this is all negative, by the way. I don't know why I didn't do that. We got 2 minus the square root of 2 all over 4 now. I think that would have been a better start, but maybe you can just jump to it. I don't know. Regardless, we got this guy. Well, the square root of 4 is something that I can actually do. So I'm going to split up my square roots like this, both top and bottom. So I just split that square root up in both top and bottom separately. Well, that square root 4 is actually a 2. Ignore the numerator. That's like just crazy stuff. And actually, that's my answer right there. So I had a negative 1/2 square root of 2 minus the square root of 2. And yes, that is all inside. There you go. Cool. Make sure it's negative. Let's keep going. 73031. Part A, I've got cosine squared of 36 degrees minus sine squared of 36 degrees. And you know what this is? I've seen this formula before. If you go back, it's right there. Cosine of 2 times the 36 degrees. So cosine of 2 times 36 is 72. And that's actually what they want you to type. I can't remember if they want those degrees like if you need to type the degree symbol in there or not. I can't remember. So just watch out, okay? They want you to write it like that. Just be careful. Just be careful. There's a part B and a part C, but it's very similar. 73038. I got cosine of x is equal to a negative 15 over 17. And they're saying that my x is somewhere between these 2 degrees, between 180 and 270. Well, what they're saying is we're down here in quadrant 3. That's what they're trying to say. So quadrant 3, if I start constructing my triangle for this, notice adjacent over hypotenuse. My opposite's also going to be a negative, but I have to go and find that. It's the 17 squared minus the 15 squared. Notice that I'm not using this as a minus sign. It's technically like this. Oops. Like that. Negative 15 all squared. Well, I know that that negative is going to go away. I know it's going to go away. You can just simplify it down to this guy. Much easier. Let's see here. I'm trying to find out what my hypotenuse was. I thought I was going to write it down somewhere. Maybe I should probably show you what they're asking for before I go all crazy on this, but I still thought this was important somehow. Well, it's not my hypotenuse, it's the other guy. You know, I didn't have to find it. I didn't have to find this other value. That's interesting. I'm going to do it anyways, but I'm going to tell you why we don't actually need it here in just a second, okay? So, like, if you don't know, while I'm recording this, I don't actually use my calculator very often because I've already done it. I wrote it down on paper. But this time I didn't actually do it. It's a negative 8. So why is it not important for me to do this little 8 thing for this problem? Well, let me give you what the problem's actually asking for first. They're saying find the sine of x over 2, the cosine of x over 2, the tangent of x over 2. So there's just formulas for this. Again, going back, we got these guys right there with the square roots. There you go. Just very repetitive. That's all it is. It's just very repetitive. Well, basically, this is going to be a plus or minus the square root of 1 minus cosine of the x all over 2. Notice that it says cosine of x, and that's going to be the theme throughout all of these formulas. We already have it. We already have it. In fact, this 8, this whole picture here is not needed. I'm going to keep it just in case, but I should be able to just simply plug in this negative 15 over 17 into each of these formulas, and we get an answer. Now, my biggest problem right now is I need to know if that's going to end up a positive or a negative in the end. Right? It's a plus or minus. I don't know. What I'm going to do is I'm going to finish off. This is a semi-finished answer. I want to box it, but I'm not. Semi-finished answer. Let me do that for the rest, and then we're going to go back and just say positive, negative, positive wherever I need to, okay? So the cosine version has a plus sign in there. And again, there's a plus and minus. Again, that's my semi-finished answer. I don't really know what that's going to be. And then finally, tangent of x over 2. I guess I went the long way. There is a quicker way, but whatever. Minus this value, 1 plus this value. If all these formulas seem like, where is he getting all this stuff? I mean, I'm literally just copying this down. I know you might not be able to see it very well from the recording, but just go to that page and there we go. And I'm not really needing to simplify this stuff, honestly. I mean, I'll give you the simplified answers here in a minute, but you don't really need it. These are my answers. These are my answers. Now, I'm going to ask, which one of is it going to be, the positive or the negative? And for each one, how do we know? Well, notice that my original x is here in quadrant 3. Okay, cool. Well, what I want to do, is find out where x over 2 is. Because here's the thing, that's what they're asking for. X over 2. Where's the half angle for this? If I took something here in quadrant 3 and I cut it in half, well, notice that we got this area, like this piece of the pie, and I cut it in half, it's probably going to be up here in quadrant 2. Okay? Now, I need to verify that. What I'm going to do is I'm going to actually divide each of these by 2. I'm not kidding you. We take the entire bounds and we divide each element by 2. And what that yields is that I got 90 degrees, and half of 270 is, calculator, 135. So where is this zone? Well, 90 is here, 135 is here, and so it's got to be somewhere in this area. Yes, you were correct. It's quadrant 2. Quadrant 2 is interesting because my sine is positive. Can you already tell what's going to go on here? Well, this is my real answer, I suppose. Here, let me just do this. Can I use the? I'm gonna color it. I'm gonna do this. There we go. Positive. My cosine is negative, and my tangent, the slope, is negative. I'm gonna write all those up here in a second. See how I'm literally just erasing it? Those are my final answers now. So again, cosine is a negative. Oh, I do not like when that happens. Hold on. Okay. Oh yeah, okay, that's fine. Cosine is a negative, and tangent is a negative. Okay, so using those, I just said positive, negative, negative. There's my answers simplified. So if you want the really simplified versions, I got a positive 4 over 7 square root 17. Here, I've got a positive, or I'm sorry, a negative 1 over the square root of 17. This is like super ultra simplified. And then finally, this guy is a negative 4 of all things. There you go. I'm not going to simplify them for you. I think this will work. If not, well, you know, do a lot of math. It should be fine, though. It should be fine. 73044. So I've got tangent of 2 times the arc sine of x. And they say, what does that equal to? Before I can keep going, I need to see this as an angle A. And so I want to find out what that is. I'm going to assume quadrant 1 if they don't say anything. So angle A, sine is the opposite over hypotenuse. Opposite over hypotenuse. And then this guy is going to be the 1 squared minus the x squared. So just that guy, I guess. We have the information needed for A. But they're saying this is 2 times that. Tangent of 2A. Is there a formula for that? Yes, you go back. It's double right there, that guy. So we got, I'm going to write it a little bit bigger down here. So erase that thing. It's equal to 2 times tangent of A divided by 1 minus tangent squared of A. Well, we have all this stuff. Tangent, again, is going to be opposite over adjacent. So then we got opposite over adjacent. Here we got opposite over adjacent. And then we're squaring that guy. There's a lot of simplifying going on here. When you square this, you distribute and do a lot of math and blah, blah, blah. I know that I'm honestly not wanting to show you a lot of this. Maybe because I'm being lazy today. Maybe because you don't really need to. I just want to show you the answers, you know, but that's fine too. When you square this thing, you got squared and the square root down there cancels. You want a common denominator, put it together. The x squares cancel one another, whatever. Actually, no, I think they combine. Same thing up here, blah, blah, blah. It's good enough. Good enough, good enough. Okay. My main concern is not simplifying stuff today. It's like, what are we doing with this trig? So they want to find cosine of 2 theta, given that we have a sine of theta is equal to negative 8 over 17, and we are in quadrant 3. So quadrant 3 is down here, okay? And this is my original theta, okay? Opposite, hypotenuse. To find my adjacent, I'm going to do the Pythagorean theorem, which I did do. It came out to be a 15. But remember that this is a negative 15 because we're, you know, going negative x, negative y, all that kind of stuff. So, cool, we have a constructed triangle. Remember that cosine of 2 theta If you go back here, cosine 2 theta is equal to, let's do cosine squared minus sine squared. And so then I say, well, cosine is going to be adjacent over hypotenuse squaring it. This one's going to be an opposite over hypotenuse squaring it. Two negatives make a positive, 17 squared, yada, yada, yada. I'm sure that you can even type this in a calculator and give you a fraction. Not 100% sure on that, but this is the thought. Whew. 3 more problems. This is a long section. But that's okay. We're gonna get through this together. I don't want to skip some just because I'm being lazy today. I want to show you everything that's important to you. Okay. They want to simplify this guy. Now notice that this is going to be a whole new formula set. I got sine times sine down here. Sine times sine. So I'm going to just use this formula. I mean, it is a straight copy paste. 1/2 cosine u minus v minus cosine u plus v. Here we go. 1/2, big parentheses, cosine of the x minus 7x minus cosine of the x plus the 7x. That is it. I am, of course, going to simplify this guy a little bit. So we have cosine of the negative 6x, and we got cosine of the 8x. I bet that's going to work, but you know what's interesting is their answer. I'm going to show you their answer here. Cosine of just plain old 6x. They switched the sign on this guy. This is their answer. This is mine. Why is it different? Well, because there's actually another identity way down here. I think it's barely on your page here. Cosine of negative theta is equal to just a cosine. What happens is that these negatives here, they cancel. They go away. It goes bye-bye. Goes bye-bye. For cosines. For sines, which you'll see here in the next problem, it actually comes out to the front. If you can see that right there, it's going to be sine of negative theta is equal to negative sine of theta. Like, comes out to the front. And that's what we'll do here in this problem here as well. They say we got sine of x minus sine of 6x. I'm trying to match this thing up. Right here, sine minus sine. Sine minus sine. So I'm going to just copy paste that guy in, and this is how it's going to look. So 2 times the cosine of x plus 6x all over 2, and then times the sine of x minus 6x all over 2. I mean, it is just a copy paste there. That might be good enough. I don't know. But I'm just going to keep simplifying a little bit since, I'm trying not to be lazy again. Notice that we're going to have a negative 5x over 2. Again, what does their answer have as a negative 2 cosine and sine. They took that minus sign and they pulled it out to the front. You can do that with a sine. On a cosine, the negative on the inside just disappears. Okay? Little rules, little rules. It's all on that big page. It's all on that page there. Oh my goodness, why is this a 5? So here's the thing. I might have just mistyped this. I might have miswrote it. And it should be a 3, but I have a 5. I don't know. I'm just looking back at my notes and I'm like, oh, that's kind of weird. Don't know why I have that. Again, you're getting that lecture experience. It's not a refined experience. No, you're not getting anything refined today. Cotangent of 2x is equal to this guy here. Notice that I just took that tangent formula and flipped it. It's 1 over tangent, so that's my formula there. Actually, that's the end of the problem. Okay, remember the main idea here is that this is 1 over tangent of 2x, and so it's the flip version, right? So I took my original that I had and I flipped it. That's the flip version. Go back and look at it at the tangent formula. You'll see it's literally the same thing. It's just that I flipped it upside down. Okay. Whew. We got through that. Thank you, guys. Have a great day, and thank you for your patience with me.